All right, last part of this lesson for stoichiometry is percent yield. And what percent yield is going to tell us is how much product we're actually making from what we should have made. And when we've been bouncing the equations and working these stoichiometry problems, what we've been finding is what we should get. However, as you know, things in nature are not always 100%. An example of this is when we make cookies. We don't always get exactly what it says we should get on the bag, and that's for reasons like we have some batter left on the bowl. Sometimes it's because we ate the cookie dough, and then sometimes it's because maybe we spilled some of the ingredients. So we never get as much as we should, and so this percent yield is going to tell us how much or what percentage we got that we should have. And so I'll let you read through these reasons why a reaction might not happen, and then let's get into the calculations. So the good news is the stoichiometry problems that we've been working are the same thing we're going to keep doing. So that part is not going to be any different. What we've been doing is called a theoretical yield, and that is what is expected. And so every problem we've been doing, when we box that answer, that has always been a theoretical yield. That means in theory, if I started with that much reactant, I could get that much product. But in actuality, when we go into the lab and we do these things, we don't always get the same theoretical yield that it says we should. And so the actual yield is what you actually get in the lab, or we can also call that an experimental value. So it's what we really, really get. And so those are the two things that we need to look for. When we're working these problems, it's really going to only be one extra calculation at the end of our stoichiometry problem. But the hard part is to know how to recognize when they're giving us an actual yield, what is actual yield and what is the reactant. So we want to look for words like produced, formed, isolated, obtained, to know that those are our clue words. And we'll practice that when we're reading through these problems to know which one is the actual yield and which one is what we should actually be beginning the stoichiometry problem with. Here is our formula for percent yield. You'll see that it's actual yield over theoretical yield times 100. And you might be asking yourself, why is this important? Why do we care? Well, I want to give you an example of manufacturers. They actually really do care about what their percent yield is, because the higher their yield is, the more product they make, which in turn means they make more money. So if they've done a setup and they're getting a very low percent yield, then they're wasting a lot of their ingredients and the things that go in to make their product. And so companies are always striving to increase that percent yield on what they're putting in as far as raw materials and what they're getting out as far as products. So that is a real world application of how we, or why we do percent yield. All right, so here we go. We have this problem that you have listed in your notes. I'm not going to read it because it's a very long problem, but what we do need to know is we need to look for our clue words. And I've underlined the two reactants, so this is going to be a limiting reactant in addition to a percent yield. And so we have our two reactants, and then it says, then calculate percent yield if 900 grams of this stuff is actually collected. Okay, and so that is going to be one of our clue words, that is going to be our actual yield. And so you will almost always be given the actual yield in the product, in the problem, and then we'll use that at the very end of the problem. So we're not going to mess with that until we find out what our theoretical yield is, because we have to find out what our theoretical is in order to be able to calculate the percent yield. So we'll start with our two reactants that they gave us. So we'll start with the zinc oxide, and I went ahead and started that problem. And so we have 6 moles of zinc oxide. Since we are in moles, I can go straight into my mole ratio. So I have 3 moles of zinc oxide, and then I'm trying to go to that crazy long one over there, which is zinc citrate. And so I'm going to say that I have 1 mole of the zinc, and I'm just going to say zinc cit to abbreviate that because it's very long to write. And then after that, I cross out my moles of zinc oxide. Since I'm in moles of zinc citrate, now I just need the molar mass. In the interest of time, I'm just going to give you that molar mass because it's rather large, and so that we can save time and write that down, 574.39 grams over 1 mole. All right, and then we do the math on that, and we find out that that answer is 1,000 150 with our correct significant figures of 3. And then we'll go look, and that's going to be grams. And then let's do the other one. So then we have 10 moles of the C6 product. And so we look at that. And again, we're in moles, so we can go straight into our mole ratio. So we have 2 moles of the carbon, the hydrocarbon, and then we still have 1 mole of the zinc citrate. So the same molar mass, grams per mole. And then when we do that math, we find out that that comes out to 2870 grams. So clearly this is the smallest one here. And so that is going to be our theoretical yield. Okay, so now we go back over here. We go use our actual yield. And remember, percent yield, the formula was actual over theoretical. And here's a little hint for you. Your theoretical yield should always be bigger, and it should always be on the bottom, okay? And so, and then of course times 100 here. So we're going to plug those numbers in. We got 990 came from the problem. So we do the 990 on top, and then we divided by our theoretical yield that we just calculated, and then we multiply by 100. And we do that, we should get an 86.2% yield. All right, I'm going to go on and do the next problem. So when we read this problem, we see if 12.5 grams of copper was actually produced. So we see that actually produced. So we know that that is going to be our actual yield right there. So they give us that number. And in this one, they also gave us our theoretical yield. It says, but if 25.4 grams of copper chloride was calculated as the theoretical yield, what is the percent yield? So this is an easy one. We don't even have to do a stoichiometry problem because they're giving it to us. So again, we have actual over theoretical. I'm going to abbreviate theoretical times 100. And then, so we just plug those numbers in. So we have 12.5 on the top and 25.4 on the bottom. And then we multiply by 100. And so when we get that, we get a 49.2% yield, which is not a very good yield. So if you were doing that in manufacturing, you would be losing some money on your raw materials. Okay, so what I want you to do for this problem and the next one, I want you to start the problem and pause the video and then try to work it out and see if you get the same answer that I get. But before we do that, let's just talk about what we have in the problem so we know we're at least starting in the right place. This says a chemistry student uses 25 grams of the lithium sulfate to react. Okay, so that is our reactant. That is what we are going to start with. That is our given. Okay, and it's reacting with excess barium nitrate. And remember, when we see those words, excess barium nitrate, that means, oh, we can ignore it. We're not going to be using it. And it says the student isolates 43.5 grams of barium sulfate. And that's one of those words that we need to look for. When we say isolates, that's kind of the same thing as it made it. So that is going to be our actual yield. And of course, we don't want to do anything with that yet because we want to save that for the end. So this is where I want you to pause the video and try to work it out and see if you get the right answer. I encourage you to please do that instead of just writing down what the answer is, because then you won't know if you understand how to do it. So pause it at this time and then come back and see if you get the right answer. All right, how did you do? If you got it right, great, move on. If you did not get it right, pause the video again and match your work to my work and see where it is you went wrong. Could be as simple as you calculated a molar mass wrong or whatnot. So just kind of try to check and see where you went wrong and then move on to the next slide. So here we go with the last problem. So let's do this. Again, I want you to, after we read the problem, I want you to pause the video and work it out and see if you get the same thing as I do. So this one says, what is the percent yield if 5.5 grams of hydrogen react, so there's our react, so that's going to be our given, with nitrogen to form this many grams of ammonia. So we see that word to form, that means that's going to be our actual yield. So again, we're going to save that till the end. So we're going to start our stoichiometry problem to get our theoretical yield, and then we'll do the last little part, which is calculating percent yield. So pause the video and work it out and see if you can match my answer. All right, how did we do? Hopefully you got a yield of 66%. If you did not, double check your work to my work. If I had to guess, the most likely mistake was this molar mass right here, because it's hydrogen and it's diatomic, but a lot of kids want to use 1.01 instead of 2.02, so double check that that's not where you made the mistake. And hopefully you got all those answers right. If you did not get those answers right, you might want to back the video up and get out a new sheet of paper and try to calculate it again and see if you get it that way. Today we're going with animal jokes. So first one, why was the parrot kicked out of class? Because he was using foul language. What do you call a sleeping bull? A bulldozer. And the last one, what do you get from a pampered cow? You get spoiled milk. All right, see you next week. Have a good weekend, guys.